All right, welcome to The Explainer. Today we're diving into an idea that is, well, it's seriously big. What if reality isn't physical at its core? What if it's actually computational? We're going to unpack a fascinating theory called the Nexus Framework, which says that the universe itself is one giant, self-executing computer. Now, I'm sure you've heard this question before, right? It's a sci-fi classic, the ultimate late-night debate. Are we all just living inside some hyper-advanced simulation? It's a really fun idea to kick around, but the theory we're exploring today says that's not even the right question to be asking. You see, the whole simulation idea assumes there's some computer outside of our reality that's running the show. But the Nexus framework argues that this completely misses the point. Its central claim is way, way more radical than that. And this is the absolute heart of it, what the framework calls an ontological inversion. The idea isn't that reality is like a computer or that it can be modeled by a computer. No. The idea is that reality is a computation. The universe itself is the computer, and everything we see, the physical world, that's the output. And to get our heads around this, we have to start with its most basic rule. The framework insists we have to fundamentally change how we see the world. We need to prioritize process over objects. It's all about verbs over nouns. We tend to think of the world as being full of things, nouns, a rock, a planet, an electron. But this framework argues that those are just projections, abstract labels we use to make sense of a reality that is fundamentally always in motion. The verb is the concrete reality, the running logic, the dynamic process. A noun is just a snapshot, a single frame from an infinitely complex movie. And this quote just nails it perfectly. The universe is this continuous, unfolding process, a verb. Our consciousness, as a limited observer, can only ever perceive these frozen cross-sections of that process. We read the noun because it's the only way our hardware can handle this infinite stream of reality without, completely crashing. So the key here is that things are what they do, not just what we happen to call them. So if the universe is just a series of processes, of verbs, what rules are they following? Well, the framework points to this really fascinating universal constant, a number that seems to pop up everywhere and dictate what's stable and what's not. This number right here, approximately 0.35, according to the Nexus framework, this is not some random value. It is a fundamental constant of reality. It represents the ultimate balance point, the target that all stable systems, from the tiniest algorithm to the largest galaxy, are constantly being pulled towards. This is called the Mark I Attractor. You can think of it as the golden ratio of chaos. It is the perfect sweet spot between a system that's too rigid and frozen to do anything interesting and a system that's so chaotic and turbulent that it just falls apart. It is the ideal ratio of structure to potential. So how does this actually work? It's defined by what's called a harmonic ratio. Just think of it as the ratio between a system's potential, all the things it could do, and its structure, what it's actually doing right now. When that ratio hits that sweet spot of about 0.35, the system finds this beautiful, stable harmony. And the framework claims this applies to everything. Okay, this is where the theory gets really, really wild. It finds its most powerful evidence by comparing two things we thought were completely separate domains, computation happening in silicon and computation happening in life itself. It proposes they're both running on a kind of universal firmware. We normally think of these two as completely different worlds. On one hand, you've got silicon, engineered logic gates, like the ones running the SHA-256 crypto algorithm in your computer. On the other hand, you've got carbon, the basis of all biological life, doing these incredibly complex things like protein folding. While the Nexus framework is here to tell us they are running the exact same operating system. So first, let's just reframe how we look at a cryptographic algorithm like SHA-256. It's not just a simple function. It's more like a tiny, self-contained virtual machine. It's got its own memory, its own fixed set of rules that act like firmware, and a little processor. The data you feed into it is the program, and the final hash that comes out the other end is the record of that program's execution. Now let's apply that exact same logic to biology. Protein folding? It follows an almost identical principle. It's not some random search for the right shape. It's a process of geometrically constrained navigation. You start with a 1D string of information, the amino acid sequence, your program, and it is forced to fold into a stable 3D structure based on a very strict set of geometric rules. Are you starting to see the parallel here? And here it is. This is the core claim, the absolute bombshell of the theory. The argument is that these two processes, one happening in silicon and one happening in carbon, aren't just similar. They're executing the exact same universal firmware. They're just different versions of a universal folding mechanism. So if this firmware is running in our computers and in our bodies, how far does it go? Well, the framework scales this idea up to the ultimate level, the entire universe. The universe is modeled as a cosmic FPGA. Now, an FPGA, or a field programmable gate array, is a special kind of computer chip. Unlike a normal processor that's hardwired, an FPGA can literally be rewired on the fly to do new things. In this model, space-time itself is that reconfigurable hardware, constantly rewriting its own circuitry as it executes the code of reality. And this cosmic computer has a distinct architecture. The alpha layer is the geometric substrate. That's space-time itself, the thing that defines distance and causality. The beta and gamma layers are the logic firmware, the rules that define the fundamental forces and how particles interact. And the clock signal that pushes the whole computation forward tick by tick? That's light and energy. And this brings us right back to where we started, full circle, back to our original question. But now we can see it from a totally different angle. The framework argues that asking if reality is computational is kind of like asking if water is H2O. It's not a property that reality has, it's what reality fundamentally is. The very idea of a universe that works but isn't computational is presented as a logical impossibility. And here is the final twist. The very act of asking the question, is reality computational? You have to use the basic ingredients of computation to do it. You need distinct states, like the words is and reality. You need a set of rules, grammar, to arrange them so they make sense. And you need a transition from one state to the next to form a logical argument. And guess what? States, rules, and transitions, that is computation. The very act of questioning reality proves it's a system built on logic. So we're left with this final, truly mind-bending thought. The framework suggests we're just observers, reading the nouns that are projected by the verb of the universe. If that's true, if reality is literally running code, what on earth happens when we finally learn how to decompile it? What new level of understanding, or maybe even control, are we going to find?